This is Unit 3, Linear Relationships, Lesson 1, Understanding Proportional Relationships, and Activity 1. This is just looking at two graphs. And the additional title of this activity is to notice and wonder. So this is just an introductory lesson. It's not meant to make you think about too much as far as remembering details. It's just really to introduce you to some ideas or review some ideas. And the first thing is that from the title of the unit, you can see that it's linear. So that means things that are on a straight line. Relationships, so things that are related in some way, two different things that are related in some way. Understanding proportional relationships. And this is really what we studied in 7th grade a lot, the idea of proportional relationships. So two things that have some relationship move together, and we'll see how all that works as we go through this. And the first part of this activity, they give you a graph, and there's some information on this graph. You can get an idea of what's going on. There's a distance that's traveled, and it's measured in centimeters. So whatever this is, these two things, so this is two different situations with the same two things that are related. So distance and time. So maybe this is two different animals, two different bugs. So this is centimeters, and this is time. Not very much time, not very far in distance. And I know that in a later lesson, we're going to look at some bugs traveling. So maybe these are two different bugs. Could be the same bug at two different times, things like that. All right, so how much distance is traveled for how much time? So a proportional relationship, notice that these two graphs go through zero. So that's one key about a proportional relationship, is they always go through zero. And proportional means that they are related in the same way. So if one part or one property, so a property of these two things is one property is the distance that's traveled, another property is the time that it takes to travel that distance. So if the distance traveled, before I get into too much detail, let's look at some examples. So let's take, for example, 3 seconds. So what happens to, and let's call these two different bugs, what happens to bug G in 3 seconds? How far does bug G go in 3 seconds compared to how far does bug F go in those same 3 seconds? So now we're going to talk about comparing the time it takes for them to travel so much distance. So that is an idea of speed or pace, and we'll talk about those things in a little bit. All right, so basically they're moving and it's taking some time to move. Well, in 3 seconds, bug G goes 6 centimeters. So 3 seconds, 6 centimeters. But in those same 3 seconds, bug F travels 12 centimeters. So notice that bug F travels twice as far as bug G does in those same 3 seconds. So 6 centimeters compared to 12 centimeters. So which bug is traveling faster? Well, if you travel for the same amount of time, but you go farther, isn't that traveling faster? So this is 6 centimeters, 12 centimeters. So F for fast. So this bug is traveling faster. Now, what's the speed of the bug? Now, a lot of this, just sit back and look at it, try to take things in. Don't worry about remembering the details right now. We're going to spend, this unit and next units talking about those details. So this is just the beginning. So this is 12 centimeters in 3 seconds. So that's its speed. This bug travels 6 centimeters in 3 seconds. So that's its speed. So now we could look at something called its pace. So we just looked at speed, which was how far it travels in a certain amount of time. So 6 centimeters per 3 seconds, 12 centimeters per 3 seconds. So how far is each bug traveling in the same amount of time? But we could ask the question, how long does it take each bug to travel the same distance? So now, rather than the same amount of time, we're looking at the same distance. So the fast bug, bug F, was right here, and it takes 1.5 seconds to travel 6 centimeters. So if you go out to 6 centimeters and you go back to this axis right here, you'll see that this is 1.5 seconds. And bug G, if you remember that bug F traveled twice as fast. So bug G, to travel those same 6 seconds, is going to take twice as long. It's slower. So it takes 3 seconds to travel those same 6 centimeters. So we have pace and we have speed. And admittedly, I get confused when I think about these two things. And so you have to have ways to try to remember those. And I'll start to show you those ways in just a moment. But again, this is just an introduction. Don't worry about it. Just kind of sit back and think about it. So we have speed and we have pace. So let's just look at speed for a moment. That's the distance that the bug traveled in 3 seconds. So how fast did it travel? It traveled, one of the bugs was 6 centimeters in 3 seconds. The other one was 12 centimeters per 3 seconds, I believe. So this distance per 3 seconds. Now, something I know about as far as speed is how fast a car travels. And I know that a car speed is measured in miles per hour. How fast are you going? Oh, I'm going 70 miles per hour, or I'm going 25 miles per hour. So how far are you going to travel in that time of 1 hour? That is speed. So when you measure the distance in a certain amount of time, that is its speed. So the distance in 3 seconds, that's its speed, or miles in 1 hour, that's its speed. Now pace is really the reciprocal of that. So how much time does it take to travel, let's say 10 centimeters? So now you're just asking the question, how long does it take a bug in this case to travel 10 centimeters? So that's like, and the way that I remember pace is I think about running. So you guys in PE, you got run laps, and maybe your PE teacher says run 4 laps. Come back and give me your time. So it's the amount of time that it took you to run 4 laps. So maybe it took you 5 minutes to run those 4 laps. Maybe it took you 8 minutes to run those 4 laps. So it's a measure of how fast you're going. How many minutes per 4 laps? Maybe it took you 30 minutes to run well, actually that wouldn't be running, to go those 4 laps. So you get an idea of speed and pace, and they go back and forth together. They are reciprocals. This is distance per time, and this is time per distance. Again, these are hard things, and you need a lot of practice looking at a lot of problems to start to sort this out. And I'm just trying to provide right now ways to think about these as we go through the unit. All right, the second graph, not much detail on the second graph. This could be anything. And so we're going to go through what you need to add to this graph to provide some information to tell you what's the graph, what the story is behind this graph. But you can get a couple of things from it. One is that it's a proportional relationship. There's 2 things. Whatever this is down here, this is one property, and this is a second property. So back here, these are properties. So for speed, one property of speed is the distance traveled. The other property of speed is the time it takes to travel that distance. Put those 2 together as far as a relationship, that gives you speed, or it gives you pace. So in this case, we have something down here. It's not labeled, but it's one property. Something up here, it's not labeled, but it's another property. But we know that those 2 properties are proportional because it goes through 0, 0. And so again, you're going to have to take some time and do a lot of problems to start to sort out what these things mean. But proportional relationship means it goes through 0, 0. And also, if you multiply one of the properties by one factor, let's say you double this property, and we'll look at some examples in a moment. But if I go from, let's find a good example here. from 3 units. So that's right on this grid line. And if I double it to 6, it's going to, this property, whatever this property is, it's going to double from 1 to 2. All right, so let's give it some numbers. Let's say we want to talk about what happens in 1 unit along this axis. Well, that answer is 2 7/10. Well, we have no idea what that means, but we do know that for one of these things, one of these properties, whatever it is, you get 2 7/10 related to that. Well, let's say it's 2 7/10 pounds. So you weigh something that weighs 2 7/10 pounds. What could this be? Well, one of the things it could be is money. So for $1, you get 2 7/10 pounds. Well, what are things that cost $1 for 2 7/10 pounds? Maybe it's 2 7/10 pounds of meat costs you $1. 2 7/10 pounds of apples cost you $1. Whatever that might be. All right, instead of $1 and getting the amount, 2 7/10 pounds, what if the question is you have 1 pound? How much is that going to cost? Well, that comes from this relationship. You can figure it out from this relationship. So instead of 2 7/10 pounds, I only have 1 pound. We divide by 2 7/10, and you divide $1 by 2 7/10. So $1 divided by 2 7/10 is going to get you right here. And again, I'm jumping ahead a little bit, but these are the things. It's a little bit of review from last year, and these are the things that we're going to do in this unit and other units. So you have 3 values: a pound, 2 different amounts of pounds, $1, and then you just have to figure out the 4th number, which is the cost for 1 pound. And that turns out to be about 37 cents. So you take $1, you divide it by 2 7/10 pounds, it equals 37 cents. And that's about right. So 1 pound is about a third of 2 7/10 pounds. So 37 cents is a little bit more than a third of $1. So those relationships seem to be correct. Now, if you go up farther on the axis, if you go to 10 pounds, so 10 pounds would then cost you how much? Well, it's going to cost you $3.50. So this estimate down here would be better at 35 cents. So it's 35 cents per 1 pound. 10 pounds costs you 10 times that much money, or $3.50. And if you double that, so this is the proportional relationship part. If I double the number of pounds to 20 pounds, what's going to happen to the price? That's going to get multiplied by that same factor. So it's going to get doubled as well. So from $3.50 to $7. So this is now starting to set up the idea of proportional relationships. Whatever factor I multiply the pounds by, I have to multiply the price by that same factor. It increases in the same way. All right. So it turns out I looked online, and I actually did find out that a head of lettuce costs 37 cents per pound. So 37 cents, and we decided that it would be better to be 35 cents, but close enough. 37 cents per pound is a head of lettuce. So these two properties, you have to add a little bit more information. You have to add what these numbers mean. So this is the weight. And what is that weight in? It's measured in pounds. So you have to label this axis down here. This is the weight in pounds. And this axis is the amount of money. And what's that amount of money measured in? It's measured in dollars. So this axis is dollars. This axis is pounds. And so you're going to look at what the cost is, dollars per pound. All right, so a lot going on. I'm just throwing out a lot of things to think about as we go through the unit. The main thing is that this is a unit on proportional relationships. So that means that there's 2 related properties of something. So you have 2 properties of a thing, Well, let's go through some examples. So speed has two properties. It has miles, it has distance, and it has time. So miles per hour, for example. So when you talk about speed, that's the one thing. You talk about speed in terms of two properties: the distance traveled and the time it takes to travel that distance. If you go into a store and buy something, it has a cost. Well, that cost has two properties to it, two parts to it. One is the money, and the other is how much you get for that amount of money. Let's say that it costs you $20 to buy an apple. Well, that's a really expensive apple. You probably wouldn't pay that much. But let's say that it costs you $20 to buy 200 apples. Well, that's a lot better. You might need that many apples for something, and so you might pay that amount of money. So you need two properties that forms a proportional relationship, meaning that they are related. All right, so this just kind of sets up the beginning. Oh, and I did find online, I just made a copy of the title of an interesting book, 13 Foods That Cost Less Than 40 Cents. I was looking for 37 cents a pound, and this came up in the search. Anyway, so proportional relationships, they're linear. This is the first lesson of Unit 3, the first activity of the first lesson of Unit 3.